All right, global wind patterns and weather. This is TEAC 8.10b. Remember, the 8 means that it's 8th grade, so all of these weather TEACs are 8th grade. You didn't have a 6-7 review this time. Identify major global wind belts and describe how they affect weather. So, going back to last week when we talked about the cause of weather and wind and all of that, we talked about how it was uneven heating. And I showed you a globe and we shined a flashlight on it. And because of that tilt, we found out that most of the direct sunlight hits the equator, so the center of the earth that separates the northern hemisphere where we live from the southern hemisphere. And because of that, it acts like a lava lamp. So where the light bulb is where the equator is. And at the top of the lava lamp, that would be like your pole. So that air is constantly moving from hot. It's rising from the hot towards the poles. And the poles is, the cold air is more dense, so it's sinking towards the equator. So that uneven heating causes the convection, which is going to cause wind belts and weather. This is at the top left corner of your notes where it says identify major global wind belts and describe how they affect weather. So weather is your answer there. All right, at the top where the little eyeballs are, it says, what patterns do you notice? So just kind of look at this and think about what patterns you see. So you're going to write 1 to 2 observations in that little box. Like, what do you notice about these little wind patterns here? Where are they located? Are they straight? Are they curved? Are they at different latitudes? Okay, so think about that and write that down at the top where the little eyeballs are. All right, so your uneven heating review. So we kind of already talked about this, but the equator is where you get the most direct sunlight. The poles are much colder, so that's where you're going to have that sinking air, and that makes convection. Hot stuff goes up, cold stuff goes down. So if you look at this picture here, you have your warm air here, and as it rises, it goes towards the poles, and then the poles, it gets cold, and then that starts to sink. And then it's kind of the opposite direction here. Your hot air goes up, but up is actually this way, and then the cold air sinks. So convection is what drives the atmospheric circulation, okay? And just remember that warm air rises and cold air sinks. And then this is kind of just a picture like what we did last week with the globe, that most of the direct sunlight is hitting the equator. All right, the Coriolis effect. So the Coriolis effect is the way the Earth's rotation makes moving air and water curve instead of moving in a straight line. So it's very similar to like trying to throw somebody a ball while you're spinning on whatever this thing is called, like a merry-go-round. Okay, you can't do it. It can't go straight if you're turning, if you're spinning. And so because of the Earth spin, okay, which causes us day and night, the rotation of the Earth also causes the winds to curve instead of going straight. So what you need to know, in the northern hemisphere, things curve to the right. And in the southern hemisphere, things curve to the left. So those are part of your answers there on that center box. So I'll give you a minute to get that. And then it says, because of this, global winds curve instead of blowing straight. Hurricanes spin in different directions depending on the hemisphere that they're in. So that's kind of cool. So an example of this would be like if I gave you a paper plate and somebody next to you was spinning, and then I asked you to draw a straight line. It would be really hard to do. So that's what causes all of the winds to curve instead of going straight. All right, global wind belts overview. So it says write down one key fact for each. So your trade winds blow from east to west near the equator. Don't pick east to west as one of your key facts because you're going to get that on the back. So these are near the equator. They happen because warm air rises at the equator and the cool air rushes in to replace it. And these winds helped early sailors trade across the ocean. So that's how they got their name. Okay, the westerlies. So we have our trade winds, and then we're going up in latitude. Westerlies blow from west to east in the middle latitudes, like the United States. So the westerlies go through the United States. These winds are responsible for pushing most of our weather across the U.S., and this is why storms usually move from west to east. So if we have rain or something coming in, like some kind of disturbance, it almost always goes from the west to the east. Polar easterlies. Polar easterlies blow from east to west near the North and the South Pole, so they repeat. Okay, so the westerlies are, you have your trade winds, which are here by the equator, and then if you go up in latitude, you have the westerlies, and then you also have the westerlies here, and then you have your easterlies up here towards the poles, and the easterlies down here towards the pole. So they move from east to west near the North and South Pole. They are cold, and because they are cold, that air is more dense, and it forms when freezing air sinks at the poles and moves towards warmer areas. And then the jet stream, not to be confused with the westerlies. The jet stream is a fast-moving river of air high up in the atmosphere, so it's high up in the atmosphere, okay? It travels west to east, and it helps guide storms, airplanes, and major weather patterns. Think of it like the atmospheric highway for the weather system. So if you are going from the west coast to the east coast, you're going to be able to get there a lot faster because of the jet stream versus if you were traveling from the east coast to the west coast. So even though the distance is the same, because of that jet stream, if you are taking an airplane, it actually kind of helps push that plane along. All right, trade winds. So flip your paper over, and this is where at the top left, notice it tells you the direction that they move. So east to west. So I included west and east on this picture because apparently we are still struggling with never eat soggy waffles, but here is the east and then it's moving towards the west. So these are our trade winds. And then you'll notice that they repeat, just like I said. So here's the equator in the center. It's still moving from east to west. So it says, imagine the Earth as a giant heat lamp at the equator, which you've imagined before. The air near the equator gets super warm, rises up, and leaves a gap. Cooler air from the north and the south rush in to fill the gap. But because Earth is spinning, that air gets curved to the west. This creates steady wind that blows from east to west all year long. They're called the trade winds because sailors in the 1500s used them like natural engine to sail their ships across the ocean for trade. Without the trade winds, global exploration would have taken much longer. So, in your blank on the back, you need to tell me that they blow from east to west. All right. Westerlies. And if you notice, a lot of these are named from where they start. So it starts in the west, so it moves from west to east. All right. Picture the middle of Earth where the United States is as a giant weather racetrack. Here, the air doesn't move straight north or south. Instead, because of the Earth's rotation, the winds curve and race from the west towards the east. These winds are called westerlies, and they're like the weather movers for much of the world. They're the reason that storms usually travel from west to east across the United States. Airplanes' flights going east are faster, and weather can change quickly in just a day or two. The westerlies act like a huge conveyor belt, constantly pushing the weather towards the east. So the westerlies are the weathered movers. They kind of push the weather along. So again, it moves from west to east. I included west and east here so you could have your coordinates, but you really should learn your coordinates on your own. All right, the polar easterlies. Imagine the North and South Pole as Earth's giant freezers. The air there is super cold, which makes it heavy and dense. The cold air sinks and then spreads outward towards warmer areas. But because Earth is spinning, this moving air gets curved to the west. That creates the polar easterlies, cold winds that blow from east to west. They're the Earth's icy breath drifting away from the poles, pushing frigid air towards the rest of the planet. So for the easterlies, you need to know that they are cold, so that air is sinking. So make sure that you include the east to the west up there. All right, now to get to the jet stream. The jet stream moves west to east. Imagine the Earth's atmosphere has a super fast racetrack in the sky. The racetrack is the jet stream, a narrow band of wind that blows really fast, sometimes over 200 miles per hour, way up high above where airplanes can fly. The jet stream forms when cold air from the poles meets warm air from the equator. The temperature clash creates a powerful river of air that zooms west to east. How it differs from westerlies, because I always get I'm like, but that's kind of what the westerlies are. The westerlies are regular surface winds that move our weather from west to east. So the westerlies move our weather, okay? The jet stream is much higher, much faster, and acts like a steering wheel for big weather systems. So while the westerlies push weather along, the jet stream decides where the weather goes. So it steers it. Okay, so on your next page, your opposite page in your notebook, you are going to label. You're going to draw this and you are going to label it. So start with a circle and then cut it in half and label that half your equator. And then you are going to go and label your trade winds and then your westerlies and then your polar easterlies. So equator, your letter C's should be your trade winds, and then make sure you draw the arrows to show which direction they're moving, okay? From east to west. And then B, letter B's, would be your westerlies. So they are going from west to east. Remember, the name tells you where it starts, and this is what goes through the United States. And then at the top and at the bottom, those are your polar easterlies. So it starts in the east and moves to the west. So you are going to get that drawn out and label it. And then we are going to move on. All right, connection to weather. Why the U.S. weather moves west to east. Global winds, like conveyor belts in the atmosphere, they push air masses and storms along predictable paths. In the U.S., we sit in the westerlies. So that's what causes us to have our winds and our weather move from the west to the east. These winds grab storms and shove them across the country like leaves floating on a river. The jet stream is a fast river of air high above us, helps steer the big storms system, and decides where they're going to go next. That's why our weather almost always travels from west to east. So, on the back, it says connection to weather. Why does the U.S. weather move west to east? List 2 reasons. You've got this. And then I showed you, this is just a little radar showing how our weather moves from the west to the east. All right, so this is the little cloud at the bottom. Which wind belt affects the U.S. the most and why? So think about which one goes through the United States and then tell me why it would affect the U.S. weather the most. All right.